Welcome to the lecture for psychopathology. We'll be talking about how we study psychopathology. So first off, let's look at some of the questions that are asked about psychopathology. And this isn't an exhaustive list, but it's some of the key questions. First being, what is psychopathology? How are these experiences that we label psychopathology different from non-pathological, normal experiences? Are they diseases? Are they temporary states? Are they typical phases of some developmental course? Right? These are all parts of the question of, what is this thing we call psychopathology? Who experiences psychopathology? How many people experience these things, and what kinds of people are they? A really big question: what causes psychopathology? Is there some common factor for everyone with the same type of psychopathology? Is it one cause? Is it multiple causes? And for this one or these multiple causes, how do they result in psychopathology? And then last, how can psychopathology be treated, right? How can people be returned to some sort of acceptable level of functioning? How can they be rid of their problematic symptoms? Okay. And we'll talk about some of the finer points of these questions in a bit, but first let's look at just some of the basic strategies that are employed to answer these questions in our field. So in terms of research designs, you have a series of descriptive designs, the goal of which obviously is to describe psychopathology, and there are multiple data sources, multiple kind of different strategies within this broader idea. Naturalistic observation, so just watching people, right? This is kind of would most likely be qualitative research here, where you're just making observations and looking for patterns, possibly not knowing exactly what pattern you're looking for, but the idea of just trying to see, well, what are these people like, and how might they be different than people who aren't labeled as, having a mental disorder, exhibiting psychopathology. Archival research, looking at existing medical, mental health, educational records of a variety of sorts, can often give us some information about psychopathology. Surveys, obviously, a huge part of our research, getting people to fill out paper and pencil things, and now with the growth of the internet, having people answer questions online, which has its advantages and disadvantages, right? Increases anonymity for people in many ways, but also leads to some questionable validity. And then one of the well-known in the clinical literature approaches would be the use of case study, right, where you are typically looking at one individual, sometimes a group, but usually one individual in depth, and usually also, again, this is kind of qualitative research where you're just writing down everything about this person and maybe making some conjectures, some hypotheses about what's going on with them, why they're acting the way they're acting, what's going to happen next, but not doing any kind of systematic hypothesis testing, as we would see in some other forms of research. And then we have correlational designs, which frequently the same or similar data sources to descriptive studies, but the goal of the research changes a bit here, right? So now there's a shift for the purpose from just describing psychopathology to also being able to looking to predict associations or relationships between variables. And as I'm sure you've heard before, but I'll say it one more time, you cannot infer causality from correlation, right? And we keep saying it because people keep doing it. But just because two things are correlated, even if it makes sense that correlation looks like it indicates causation, you can't be sure. And as I'm sure you also remember, it's because of the directionality problem. If A and B are correlated, you don't know if A caused B or if B caused A. So he can't infer causality because of directionality and also because of the third variable problem. So again, if A and B are related, it could be that A isn't causing B and B isn't causing A, but there's some third variable, C, that's causing A and B, and that is what's causing there to be a relationship between A and B. When you do correlational research, typically you calculate a correlation coefficient, which will tell you something. It'll quantify the size and the direction of the relationship, right? And in terms of the size, the correlation coefficient will range from 0 to plus or minus 1, right? And a correlation of 0 is a very weak relationship, right? That means there's no systematic relationship between two variables. And then a correlation of 1 or negative 1, so the further away you go out from 0 to the right or to the left on a number line, indicates a strong relationship. So a 1 or a negative 1 indicates a perfect relationship, right? So with a perfect relationship, that means that if you know how different two people are on one variable, then you could calculate exactly how different they are on the other. You could predict that perfectly if they're perfectly related. And typically, when we talk about correlational studies, we're talking about looking at linear relationships, but not necessarily. There are statistical techniques to look at relationships that are nonlinear, that are curvilinear. But like I said, the correlation coefficient will tell you about the size of the relationship, and then the sign of the correlation coefficient tells you about the direction, right? So a positive correlation or a negative correlation. If two variables are positively correlated, that means they co-vary in the same direction, right? So if things co-vary in the same direction, the key part there is same direction. So if there's an increase in one, that means there's an increase in the other. If there's a decrease in one, you can expect a decrease in the other. Whereas a negative correlation means that they co-vary in opposite directions. As one increases, the other decreases. As one decreases, the other increases. Right? Okay. So we have descriptive research, correlational research, and then we kind of moving along this kind of continuum of I almost want to say basic research to more complex research. We get to quasi-experimental designs, which are really halfway between correlational and experimental research in many ways. And the goal here is to identify group differences. And the kind of the underlying belief, the expectation is that these differences, may reflect some sort of cause and effect relationship. But you can't be sure because of the way the research is conducted, and that's why it's still kind of like correlational research, because you're comparing two groups, but you didn't assign people to be in these groups. They're pre-existing groups typically, and because of that, you can't infer any kind of causal relationship just because they're different. So since you don't assign people to a group, you don't manipulate an independent variable. That detracts from your internal validity, your ability to be confident about any kind of cause-effect relationship. But you can take steps to try to increase, your confidence that there is a causal relationship. You can't ever be sure, but you can say, well, it seems pretty likely because I've done these things. One approach is to use some sort of matching strategy, right? So because one reason you can't infer causality. Okay, I found these two groups that are different. One group are widowers, and the other group is not, and they're different in terms of mood. And so I think they're probably different. The moods are different because, one of them lost their spouse and the other didn't. But since I didn't manipulate that, I didn't assign them to groups, I can't be sure, right? The two groups might differ on some other variable, right? So maybe there's some other variable that's related to the other variables I'm looking at. And so what you might try to do with a matching strategy, if you're worried that the two groups might differ on some other variable than the one you're looking at, some third variable, think about kind of correlational study we just talked about, then you match people on that kind of variable you're worried about. An example, if you think of a better example here, if you think that flu shots cause depression, right? And you aren't able to assign people to get flu shots, you just go and ask, hey, did you get a flu shot, yes or no, and you measure depression, right? and you want to compare those who got shots to those who don't. There might be some third variable that could affect depression, and that could also affect which group the person was in. So you might think, well, I think socioeconomic status might be related to both of these things, right? Socioeconomic status might predict your ability to get a flu shot, and it might also be related to depression. If if we think about lower SES being associated with more stressors and more anxiety, which puts you at risk for depression. So if you think that SES might be kind of this confounding variable, this third variable, then you have these two groups, one that got flu shots, one that didn't. Then you start matching people. So you compare, you match people on SES, and you compare these pairs, right? So you get the two poorest people from each group. So the poorest person who got a flu shot and the poorest person who didn't get a flu shot, and you compare them to each other, and you get so you get the richest people in each group, and you compare them to each other, and so on and so forth, all the way down. You match people up, and you compare each pair. That way, you're in some degree controlling for differences in SES. But I say some degree, and whenever you hear studies saying that they've controlled for pre-existing group differences, recognize that that's not true. You can't control for the differences. You can attempt to statistically control for them, but you don't make people not different by matching them. You simply match them. So matching solves one problem, but it introduces several others. And even a really well-designed quasi-experimental study that uses kind of sophisticated matching, you still can't be fully confident that there's a causal relationship there. So be cautious how you interpret the results of any kind of quasi-experimental study. And don't trust people that say that they've controlled for pre-existing group differences, because they can't. They've reduced some variability in there, but that's about it. Another kind of sort of quasi-experimental design would be a field experiment, what you might also hear referred to as experiments of nature, right? So these are a type of quasi-experiment where you take advantage of naturally occurring phenomena as independent variables, right? So maybe you measure well-being in soldiers before they deploy, and then again after they deploy. And you can't manipulate or control what happens to them during their deployment, but we can study the differences pre and post. So, okay, these people, I'm going to now go back and find out all the soldiers that were maybe in a firefight, and then I'm going to look at, okay, what were their scores on this measure of well-being before they got in a firefight? What were the measures after they got in a firefight? Right? But again, I can't be absolutely 100% positive that any kind of change is related to that thing that happened, because I didn't assign them to any kind of conditions, and more than that, I didn't have any experimental control. Right? Other things will happen to them other than a firefight, and I can't know everything that happened to them. But I can still kind of conjecture about possible causal links. Okay. Computer's frozen up here. What's going on? Oh, there we go. Sorry. Another type of quasi-experimental design would be most types of developmental research. Right, when you're looking at people across time at different stages of development at one point in time, or both, right? So a longitudinal study is when you follow some group of people across time, right? And you can't manipulate time, so it's not a true independent variable. So in that sense, that's a quasi-experimental design. And then a cross-sectional study, instead of following people across time, which is expensive and difficult to do, and they might drop out. There's all kinds of problems with that, especially when studying psychopathology, because it's hard to keep anybody in a study for a long period of time, but really people who are suffering from mental disorders, really hard to keep them in a study just because of all the other things that they have going on. They don't have much time and energy to spare to stay in your research study. So longitudinal studies are great not always realistic to do. So you might try a cross-sectional study, and that's where you're getting people who are at different developmental stages, and you're just getting them all at one point in time, right? So you'll get some fifth graders, you'll get some kids in high school, you'll get some college students, you'll get some young adults, you'll get some people who are in middle adulthood, and you get some older adults, and you'll study them all at one point in time and look for differences across these groups, which can tell you about differences at different stages of development, but it can't tell you necessarily about how people change, right? Because kids who are in fifth grade now are probably different than you're also looking at like some older adults, and those older adults probably weren't like those fifth graders now when they were in fifth grade. So you're not necessarily looking at change, but you can look at differences. And then cross-sequential designs is really just a combination of longitudinal cross-sectional research. That's where you get that cross-section. You have people from multiple points in development, and then you follow all of those groups across time. And cross-sequential designs really address the problems in both longitudinal and cross-sectional designs, but they're also very expensive and hard to do. But ideal if you can manage that. And then the kind of the gold standard in research would be the experimental designs, right? Experimental designs are the only ones that you can draw cause and effect conclusions from, and they're designed, and your goal when doing the experiment is to make it as to increase your confidence in your cause-effect conclusions as much as possible. Right? You want to do everything in your power to, when you have any kind of results and they're statistically significant, right? You have some group difference. You want to be able to say, okay, that group difference is because A caused B. Right? And to do that, you have to do a couple things. One, random assignment to levels of the independent variable. Right? So that means that you go and you get a sample, and if you have an independent variable that has two levels, kind of a simple experiment, so a treatment group and a control group, you don't let people choose which group to be in. You don't say, okay, first half of the alphabet here and second half there, because that's not random either, but you randomly assign such that everybody in your sample has an equal likelihood of being in one group or the other. Okay. And sometimes people get that confused with random sampling and think, oh, well, you have to have random assignment and random sampling. Random assignment is necessary to conduct an experiment. Random sampling is not. Random sampling is about building your sample. And if you have a random sample, it means that everybody in the population that you're studying has an equal likelihood of being in your sample. That's rarely done. It's expensive, and it's not really necessary. It's nice. It's helpful for generalizability. So if you find something and you want to say, okay, the group that I found this effect in, this effect probably is true in the entire population. If you have a random sample, you can be more confident about that. But again, generalizability isn't as important as internal validity and your confidence in the cause and effect relationship. So random sampling, it's nice if you can get it, but it's not essential for an experiment, whereas a random assignment is, and they're different things. In an experiment, you manipulate an independent variable and you measure a dependent variable. Right? And when we say manipulate an independent variable, that means that when you have these two groups, you decide who's in one group and who's in the other, and you decide what happens to them. You don't let them choose what happens to them or which group they're going to be in. And then we measure the dependent variable, and there are multiple ways of measuring dependent variables. But basically, we're going to manipulate the IV to see, okay, how are people different on this other measure, on the dependent variable? Does it depend on what we did to them, what group we put them in? Does the dependent variable depend on the independent variable? And that's the goal of the experiment. So we use random assignment, we manipulate an independent variable, and then the third kind of hallmark of experimental design would be exerting experimental control. So this is about making our when we have groups, if each level of the independent variable represents a group, we make our groups as similar as possible, with regard to who's in them, and also with regard to what happens to them. When we do that, we're again increasing the confidence that differences in the DV after manipulating the IV are due to the IV and not some other extraneous variable. Okay. So now I've said this phrase already a couple times, so I'll say it one more time. Experiments are all about maximizing internal validity. It's of central importance. We need to be confident that group differences are due to the independent variable. And to do this, again, we design a tight experiment. We use random assignment. We manipulate our independent variable. We exert experimental control as much as possible. And then we design our experiment in such a way that we can account for any kind of plausible rival hypotheses or explanations. So if you think about a study at the end and you find this group difference and you say, well, I think it's because of this, you have to be able to anticipate, okay, what else might people say? Why else might these groups differ? And then try to then work backward. Okay, now what can I do in my study to make that explanation not make any sense and not be valid and be accounted for? And that's of primary importance. Of secondary importance to a study would be external validity. And external validity isn't necessarily overall not as important, but it's not as important for an individual study. External validity is about the degree to which conclusions you draw from your findings are generalizable, applicable to other people in other situations that differ slightly from the people and the situations in your particular experiment. And often there's kind of a tension between internal and external validity. A lot of times the decisions you make to maximize internal validity lead to decreases in external validity. And this is especially true in research looking at psychopathology. Excuse me. Like whenever we're trying to find anything about psychopathology, so treatment study looking at depression. One thing that you do to maximize internal validity is you try to get a homogeneous group of depressed people. Right? You don't want all kinds of different depressed people in your study, because if you do, it's harder to find an effect. If you have some really severe, some mild, some moderate, and you give half of them treatment, half of them not treatment, it's harder to see if treatment had an effect if you have all this other variability in depression. So you're probably going to limit who's in your study to maybe just moderate or just mild or just severe. But whatever things you do to limit your sample, even though it may increase your internal validity, make it easier to find an effect and be confident that the treatment worked, it then gets in the way of, well, it worked for this group of people that are like this, but what if people are slightly different? What if they don't have primarily vegetative symptoms? What if they don't what if they're actively suicidal at the time? Will the treatment still work for them then? You don't know. But again, my recommendation to you when looking at studies is you don't say, oh, this study is the best study, has no external validity, but go, okay, who does it apply to? And then are there other studies out there that will can kind of extend the external validity of the findings, because that's how it should be done. One study finds it with one group, and then when you say, well, does it work with this other kind of people? Somebody else, hey, you go do another study and see if that's true. So external validity ideally comes from a combination of studies and not one uber study that studies all kinds of people in all kinds of situations. Okay. Regardless of which approach is used, or the ones we just talked about, research in the social sciences almost inevitably involves the measurement of variables, and in the case of experiments, also the manipulation of variables. And there are some important concepts we should discuss related to the measurement and manipulation of variables before we go any further. So we talk about reliability, right? And reliability is the degree to which a measurement is consistent. So if we think about precision and accuracy, reliability is about precision, right? So if you think about throwing darts at a dartboard, whether or not you hit the bullseye, if you hit the same spot every time, you're very reliable, right? And there are different types of reliability. Inner rate of reliability, we've already talked about, is important for diagnostic categories and for tools used for diagnosis. It's important for people to agree on, okay, given what we know about this person, we all agree that they have that they have this diagnosis. I mean, there's high inter-rater reliability versus, oh, I think they have bulimia. No, I think it's anorexia. We disagree. There's poor inter-rater reliability. Retest reliability is obviously about time. So if you measure something at one point in time and then measure it later, do you get the same results? And whether or not this is important depends on what you're looking at. If the thing you're measuring is supposed to be stable, then you want high retest reliability. If it's not necessarily that's very stable, then you may not really be that interested. Like if you have some instrument that measures symptoms in a panic attack, then it may not have high retest reliability. Like, how somebody scores during a panic attack and how they score when they're not having a panic attack should be different, right? You should have poor retest reliability in those situations, right? But if we're thinking about things that are thought to be stable, some sort of measure of dysthymia, right, which is a disorder characterized by this ongoing long period of depressed mood, right, at least 2 years of depressed mood, that should be fairly stable over time, how people score on that measure. And then internal consistency, again, depending on what you're measuring, this may or may not be as important. So, but generally when we talk about internal consistency, we're talking about a construct that's unidimensional, and we're asking multiple questions about this one thing. And all those different questions should correlate with each other. So if you scored highly on one question, you should score highly on all of them. If you score low on one question, you should score low on all of them. But again, it depends on what you're talking about. If we have a measure of love, right? If I have some questions in there that measure filial love, they probably wouldn't correlate with, hopefully, with some other questions in there that are measuring romantic love. Right? But that's because love isn't unidimensional. There are different factors, different types of love that we could look at. And if I broke that down in some measurement and had different scales, then I'd look for internal consistency within my subscales, but not necessarily within the whole measure. So again, depends on what you're talking about. And then there's validity, which again, validity requires reliability, but reliability isn't sufficient for validity. And what validity is about does something measure what it's designed to measure? So again, think about, that's out of order. Okay. Sorry. Our kind of accuracy and precision. Reliability is about precision, and validity is about accuracy. So we're going to think about our dartboard metaphor. So if you're hitting in the same place every time, but it's not the bullseye, then you don't have validity. This is about hitting that bullseye. Right? And if you hit it just once, well, that's not accurate either. Right? If you hit it every time in where you're supposed to hit it, then it's reliable and valid. So reliability is required for validity. And the overarching term that's often used in measurement for validity would be construct validity. So does a measure what it's supposed to? And there are different aspects of construct validity. Sometimes people talk about convergent and divergent validity. Convergent validity is does the measure relate to other measures that it's supposed to? And divergent, does it not relate to things that it shouldn't relate to? Right. So if I create a new measure of depression, it should correlate. Somebody takes my test, and then they take the Beck Depression Inventory. The scores on those two tests should correlate, right? But then if they took an IQ test, the scores on my depression test shouldn't correlate with IQ scores, right? Those things aren't conceptually related, so they should diverge. And then there's criterion validity, which is all about how well a measure relates to some outcome. And we can think about it, how it relates to an outcome now, which would be concurrent criterion validity, or how it relates to some future outcome, predictive criterion validity. Okay. And then, as you see here, standardization, which is important, it's a process of establishing specific norms or standards for measuring something, right? So you have when we talk about standardization for assessment and measurement, usually we're talking about having standardized procedures, so everybody gets to test the same way, so it gets rid of some of the clinician bias. Oh, I think they have this, and I'm going to give them this test, and it's going to show what I want it to show. If you have to give it the same way to everybody, you have to ask everybody the same questions, then it's harder to let your biases influence the outcome. The other thing that allows for are normative comparisons. When you have a standardized instrument, there's some subject pool that already took the test, and we know what the average score is. We know what high scores are. We know what low scores are. And this is particularly important for psychopathology, because we often define abnormal or pathological statistically, right? And what we do is we look at some group of people that have taken this test already, and if a client is 1.5 to 2 standard deviations above the mean, depending on which test we're talking about, but far enough above the mean that it's rare, then we say, okay, that's clinically significant, right? And we recognize that not everybody is average. Not everybody will be right in the middle. Some will be slightly up, some will be slightly low. But if you're really up, and again, 1.5 to 2 standard deviations above the mean, now we say, okay, there's some psychopathology here, and it's important. It's something to look at and consider as a target for treatment. Right? Okay, so big picture here, if the variables in a study aren't measured reliably and not in a way that accurately reflects the constructs being discussed, or if the variables being manipulated don't accurately reflect the constructs they're supposed to represent, it doesn't nullify or negate the findings of a study, but it does significantly limit the interpretations that can be made. Right? It limits the confidence in the cause-effect relationship, and it limits generalizability. Because once you screw up your internal validity, then you've got no external validity either. Right? If you're not sure that there is a cause-effect relationship at all in your own study, then there's no way you could generalize that cause-effect relationship outside of your study. Okay. Okay, now let's get back to those questions and some particulars about them. What is psychopathology? And to answer this question, primarily we use descriptive research strategies and some correlational strategies. Also a lot of use of archival data and surveys. It's asking people questions. And one statistical approach to doing this is cluster analysis. It's a statistical procedure for identifying groups of people that differ on some set of variables. Right? So we ask a bunch of questions, and we find, okay, well, most people say that no, I don't do this, I don't do this, I don't do this, I don't do this. But there's one group of people that says, oh yeah, I frequently have these obsessive thoughts and these compulsive behaviors, and it's not. It doesn't occur on a continuum such that, okay, most people have a little bit, and some have a little more, a little more, a little more. It's not this nice normal distribution, but it's this clear separation of, here's this one group of people that reports these behaviors or these experiences on some variable, and they're different from these other groups of people. Right? And that's a cluster analysis. Similar to that is factor analysis, which is a statistical procedure for identifying if some measure of a construct is unidimensional or multidimensional. So cluster analysis kind of identifies clusters of people, and factor analysis identifies clusters of variables. Right? So if we were looking at the experience of depression, and you have all these different questions about depression, and you ask them to a bunch of people, and you look at how they respond. And if really depressed people answer really high on every single question, and people who aren't depressed at all answered really low on every single question, then it's completely uniform, it's internally consistent, and it's unidimensional. There's one factor. That might happen, or you might find that some people answer a bunch of questions really high related to the somatic or physical symptoms of depression, but not as high on the cognitive, or maybe some are high, some are low, but it's not predictably related to that. And then same with the affective symptoms. But you have these different clusters of symptoms, where people answer all these somatic questions the same, they answer all the cognitive questions the same, and all the affective questions the same. But your score on the affective questions doesn't tell you necessarily anything about where you're at on the other two factors. And these factors will emerge in factor analysis, and you find, okay, it's not a unidimensional construct. There are different aspects of depression that we can reliably separate into these different factors. And so that can tell us about the nature of some of our disorders. And sometimes there are more factors than we think. And sometimes we think things are multifactorial, and they're really unidimensional. Right? And the statistics can help us parse that out. Okay, and then kind of a broader term that might include at some point in time cluster analysis, factor analysis, would be your taxonometric search procedures, which basically examine the mathematical relationships among variables that differentiate one group from another. So looking at patterns of correlations. Again, think about those concepts of convergent and divergent validity. It's the same kind of idea of looking for things that are related and not related in a systematic way. So, if there is such a thing as schizophrenia, then people who are labeled with it should be similar to each other on several relevant variables. And they should be different from other people, both people in the community, right, normal people, and also different from people in clinical samples. So they should be different from people with other forms of psychopathology, right? And one of the things that we've found using a variety of taxonometric search procedures is that the disorders we're currently using in our current taxonomy differ in their taxonicity. Right? What I mean by that is some disorders are clearly taxonic. They're a group. So, okay, the people that they're labeled schizophrenia, they're like this, and they're qualitatively different from people who don't have schizophrenia. Other disorders, especially the personality disorders, seem less taxonic, less group-like. They seem more to be not categorical, but more on a continuum. So, dependent personality disorder, people that have difficulty making decisions for themselves, feel the need to be in a relationship and rely on others for a sense of identity. That seems to be on a continuum where some people are on one extreme where they don't rely on anybody and are super independent, but then it moves kind of slowly toward some imaginary middle, right, where not super comfortable but completely alone, but not overly reliant on other people. And then there's not a chasm between that and dependent personality disorder. It seems that there's this continuum that some people are slightly more, and at some point a line gets drawn and we put the box around it, but it's really not a separate taxon. It's this kind of continuous phenomenon, and that presents some problems in our research and in our other work. Given the differences in taxonicity. For the most part, we just pretend that they're all equally taxonic and they're all good categories. But hopefully with DSM-5 coming out in the next couple of years, we'll see some shifts there and get a better idea of the different how differences in taxonicity relate to how we need to think about these disorders. Okay. Related to that is the taxonomic dilemma, right? So taxonomies, like the DSM, are based on grouping together symptoms that have manifest similarity, right? Behaviors that look the same, symptoms that look the same. The problem is that manifest similarity and latent similarity, and latent, we think about latent being some sort of truth that's not readily observable. Manifest similarity and latent similarity may not line up, right? We could have two clinical presentations that look the same kind of symptom patterns, but they're the result of different disorders, so they don't have latent similarity. But we can also have two clinical presentations that look different, right? So manifestly different, but really they're the result of the same disorder, i.e. latent similarity without manifest similarity. And this is especially problematic given that we know that the manifestation of psychopathology changes over time, but our diagnostic criteria don't take these developmental shifts into account. So what does this dilemma mean for us? Well, it means, we're not 100% sure we know what psychopathology is, right? Where the lines are drawn, or if the things we're calling this particular name, if everybody is the same in terms of the latent variables, the truth underneath the labels, if there's the same truth there. Right? And if we can't be 100% confident about that, well, then we can't be too confident about any of our other research endeavors either. It's kind of a limiting factor for us. Okay. All right. So, beyond trying to figure out what psychopathology is, where the line is, what the disorders are, and what they're like, which we're still working on, another major question is who experiences psychopathology. Right? And typically we use descriptive and correlational strategies to answer this question. And the broad term that applies here would be epidemiology. Right? Epidemiology is the study of the distribution of disorders in a given population and the variables associated with that distribution. Now, there are multiple reasons for epidemiological studies and needing an answer to this question. Briefly mention two. One, it's important in helping us figure out how and where to direct funding for prevention and treatment. Right? We need to know how many people have disorders, where they're at, what they're like, what kind of resources they have, to figure out where we're going to spend our dollars helping people get better, or to keep them from having problems. Two, with good epidemiological data, ideally we could identify risk factors. If certain variables are found to be related to the prevalence of psychopathology, then we'll have a better idea before people are showing symptoms. Okay, if you have these characteristics, if you are been married this many times or divorced this many times, if you have this many kids, if you have this level of education, this level of income, live in this area of the country, then you're at a high or a low risk for this disorder. Right? And then if we know that, it's again possible that we could help with some preventative efforts. Okay. Important terms when talking about epidemiological studies, and things to clarify. Prevalence, which is often confused with incidence. Prevalence is how many cases there are, both new and old, at some point in time or over some period of time. Right? So the current prevalence of PTSD, or the lifetime prevalence of PTSD. So in people's lifetime, in some population, what percentage of those people can be expected to develop PTSD at some point in time in their life? Right? Or it could be today, right now. How many people currently, at this point in time, have been diagnosed with PTSD? What is the current prevalence rate? Right? Which is different from incidence. Right? Incidence is the number of new cases over some period of time. So the 1-year incidence, the 10-year incidence. And you usually have to specify in 2005 the 1-year incidence. So in this period of time, there were this many new cases. The current prevalence is this. The 1-year incidence is this. So we can expect in 10 years the prevalence will be, at this point. Okay, it's important to kind of touch on some of the biases that may exist in epidemiological research. The validity of the conclusions drawn. We've talked about internal and external validity. The validity of the conclusions drawn from epidemiological research often depend on how the sample was created, because it's not feasible to measure the entire population of interest usually. So you have to draw a sample, and how you do that will influence what you conclude, what you're able to conclude about the population. One phenomenon of note is the tendency for studies done in clinics, in clinical settings, to overestimate comorbidity. Right? We've talked about comorbidity is kind of a problem, but if all the people we're looking at come from clinical settings, and we look at, well, how many other disorders do you have? We may think, wow, people that have depression have a high degree of comorbidity. Well, maybe not. People who have depression and went for help have high comorbidity. But is that true of all people who have depression? Maybe not. Because generally, people with comorbid disorders are probably more likely to present for treatment than people without comorbid disorders. Right? Last thing I want to talk about in terms of who experiences psychopathology is prediction. As I said earlier, one of the goals of epidemiological research is to kind of discover patterns among variables, to be able to predict who will exhibit pathology or how many people in some group might show it. Right? Now, the ability to make meaningful and accurate predictions, i.e., your predictive power, depends on the sensitivity and specificity of the procedures you're going to use. So your sensitivity is the ability to correctly identify people with the problem, and specificity is your ability to correctly identify people without the problem. Right? So it depends on sensitivity and specificity, but also depends on the base rate of the disorder or the problem you're looking at. Now, in general, to have high predictive power, to have be able to make meaningful and accurate predictions, you want high sensitivity and specificity. But then you want your base rate to be moderate, right? If your base rate's too low, if it's a really rare thing, then it's going to be really hard to have good sensitivity and specificity. It's going to be hard to predict who's going to have that disorder, because it's just so rare. But on the other hand, if the base rate's really high, then you might be able to do a really good job of predicting who has it, but you may not do a good enough job, right? The utility of prediction dwindles because you might be even more accurate just by predicting that everybody has the problem. If 90% of the population has the problem, if you say, okay, well, if anybody comes in, I'm going to say they have it, I'll be right 90% of the time, and that's pretty good. So you want high specificity, high sensitivity, and a moderate base rate. Moving on to the larger question of what causes psychopathology. Again, important to differentiate between a couple of terms. That's really weird. Etiology versus pathogenesis. Etiology is about the cause of a disorder of psychopathology. Right? So there's this thing or this process that caused it. And pathogenesis is the process by which the causative agents result in psychopathology. Right? So there's a recognition here that it's not as simple as A then B. Okay, somebody was scared by a mouse and they have a phobia. So there's not kind of a single etiology. We know that there is this pathogenic, there's this pathogenesis, a pathogenic process, whereby usually multiple etiological factors contribute to the development of psychopathology. And again, when we say development of psychopathology, psychopathology is not an end state. It's a current state that somebody's in. They meet criteria for a disorder. They're exhibiting some symptoms. What symptoms they're exhibiting, what dysfunction they're experiencing, will not be the same tomorrow as it is today. Right? So it's continuing to develop. It might be getting worse, might be getting better, but it's always changing. Okay. One of the things that's currently believed is that, as I've already alluded to a bit, that multiple variables, both organismic and environmental, combine and interact And these variables are predisposing factors, right? And they combine and interact to create a predisposition or vulnerability to psychopathology. Right? And none of these predisposing factors is thought to be individually necessary or sufficient to cause psychopathology. So having one predisposing factor, not enough to give psychopathology. But at the same time, we say look at somebody and we find all these predisposing factors, and they have these 4 predisposing factors. If they didn't have one of them, they might still have had experienced psychopathology. So they're not required individually, and individually they're not also sufficient, but they somehow work together. And it's generally believed that the more predisposing factors someone has increases their vulnerability. But this isn't all that straightforward either. It's not necessarily this kind of simple additive procedure. Not all predisposing factors are probably equal in their degree of influence, and they can also interact in really complex ways that, in general, circumvent a simple additive approach. Okay. But again, we've kind of figured out that it's a lot of things working together to create a vulnerability. When we think about these predisposing factors, we differentiate those from precipitating causes or precipitating factors. So you can be predisposed, and then we also think, well, okay, there's certain things that seem to be kind of like the tipping points, right? And these are factors that researchers, certain events or conditions that seem to be, like I said, a tipping point. They often immediately precede the onset of the manifestation of pathology. Right, the latent disorder or the vulnerability may have been present but didn't manifest until something pushed the person over the edge, and that could be a traumatic event. It could be accumulation of stress. Could be pregnancy. Puberty, some sort of biochemical shift. Lots of different things could be precipitating factors, and the factor didn't just cause the disorder, but it's kind of the last thing. And oftentimes the precipitating factors are the ones that we're more aware of, and it's harder to kind of discern those predisposing factors. They're kind of in the background. And in addition to predisposing factors and precipitating causes, we also have risk factors. And risk factors might be predisposing factors, they might be precipitating causes, but they also might be things that have really no causal relationship with the pathology, right? So a risk factor might be something that simply is correlated with the pathology, but isn't related in a causal way. So the number of ashtrays in your house is probably a risk factor for cancer, right? And the number of ashtrays, the ashtrays aren't going to cause cancer. But if I know the number of ashtrays, I can have some idea of how likely it is you're going to have cancer. So therefore, it is a risk factor because it's predictive. And again, being predictive doesn't mean causative. People often confuse those things, especially when talking about sensitive things like education level or income as being risk factors. And it's not because they're causative, but they are markers. They are correlated with certain outcomes. Okay. Another idea I want to touch on here is the difference between equifinality and multifinality. Equifinality is what we've kind of already talked about, that you can end up in the same place from different paths. Right? Equifinality, same final place. Right? So people that get the diagnostic label obsessive compulsive disorder, there are lots of different ways to have gotten there. Different combinations of predisposing factors, different precipitating causes. Right? Some people could have genetic predispositions. Other people might have less of a genetic predisposition or no genetic predisposition whatsoever. People differ in their environmental variables. It's all these different combinations, but they can still get to this same place, which again makes things tricky and a bit messy. And the other end of that, the other idea here is multifinality, which is excuse me. given that certain predisposing factors or precipitating causes can result in different forms of pathology, right? So somebody might experience, two people might together experience the same traumatic event. Right? And we think, okay, well, trauma leads to this. Well, not necessarily. One person who experienced trauma might develop PTSD. The other person who experienced trauma might then develop anorexia nervosa. Right? So we can end up in the same place with different kind of causal things in the background, and we can have the same kind of causal events, at least some of them, and then end up in different places. And usually we end up in different places because there are these other causal things that are different between the two people, right? If two people have exactly the same causal events, then they should end up in the same place. But having exactly the same causal events, 1 in a billion, right? Because you'd have to be genetically identical and then have the same environmental experiences as well. And that just doesn't happen with people. Might happen with some lab mice, but with some exceptions, most people are not lab mice. Okay. Other things that we know about studying what causes psychopathology. When studying psychological theories, and there are a variety of psychological theories. You have your kind of psychodynamic, you have your cognitive, your behavioral, your social learning stuff. One thing about these theories is it really relies on programs of research that kind of put together pieces of a very large puzzle. Right? Experimental research contributes here, but just kind of it's like bits at a time. It's not tenable, not possible to test large chunks of a theory about etiology experimentally. Support for a theory requires converging evidence from multiple studies. For example, if you think that depression is related to cognition, right? So you might think, well, maybe it's pessimistic thinking. So we're going to conduct an experiment where we make some people think negative thoughts, and we make other people think positive thoughts, and then we measure their mood and see if they're different, right? So in this analog study, the proof, even if we find that, it's not definitive. Okay, well, yeah, and clearly then everybody's depression is caused by this thing. Just because we can cause something in an experimental setting doesn't mean that it is caused by the thing that we've shown is possible. Right? But we can start showing clues with different studies that can add up over time. The other thing that's often done when trying to study psychological theories is looking at developmental studies, which again are kind of correlational, quasi-experimental in nature, which limits your ability to draw conclusions about cause and effect. And generally what you do are either retrospective or prospective studies of development, more often than not retrospective studies, where people that have some disorder, and then maybe if you're in a good study, some people that don't, we have them recall, okay, what was your childhood like? Our theory suggests that, your father would be overbearing and your mother would be cold and indifferent. Right? And we ask people, okay, what were your parents like? And they ask people, what are your parents like? And we look for differences. Right? And that can give you some evidence, but again, there are some significant problems with these types of studies. You're not assigning people to groups, and you're also relying on memory and self-report. And we know with psychopathology that certain forms of psychopathology are related to distortions of memory. When people are experiencing a major depressive episode, they're more likely to recall negative events than positive events. Right? The same person, when they're not depressed, they'll more easily recall positive events than they will negative events. So pathology affects what you're going to recall. So that can distort that. Better studies are the prospective ones, where we identify people and we follow them over time. Those are kind of your longitudinal studies, which again are great, but expensive and difficult to maintain. Okay, when studying genetic influences, one thing you'll often read about in studies reporting genetic influences in psychopathology are reading about heritability and heritability estimates, right? And heritability is the extent to which individual differences in a characteristic are attributable to genetic factors. And a heritability estimate is supposed to be a mathematical quantification of this construct, but it's really not, because what it tells you, a heritability estimate tells you the proportion of variability in a trait that's related to variability in genes. And related to is not the same thing as attributable to, because attributable to sounds like caused by. And any kind of heritability estimate is done using a correlational design, because we can't assign people to be more or less genetically related to each other, right? Those are pre-existing differences. Okay. So that in itself makes it hard to interpret. The other thing is the fact that this is all about comparing or measuring a relationship between two types of variability. So it can be misleading. And I really like the example. It talks about how the heritability of the number of legs that you have. The heritability of number of legs in a population is close to 0. Right? But the number of legs you have is most definitely influenced by your genes. And people think, well, heritability means how influenced is a trait, how genetically influenced is a trait. And that's not what it is. It's not what it is. It has to do with differences in genetic variability and the degree to which that those differences are associated with differences in a trait, which can give you some clues to a possible genetic role, but it's very correlational in nature and should not be interpreted as causative, although it is time and time and time again. So just my advice would be to almost just ignore heritability estimates altogether, because they're mostly misleading, and the point that they can get across, you probably already know, is genetics play a role in everything, including psychopathology. Other issues in studying genetics: family studies, which are often used to create heritability estimates. What these do is they look at differences in degree of genetic relatedness, because some people are more genetically similar to you than others, right? And they can sort of estimate that, right? Because we know the average degree of genetic relatedness, of biological relatedness. And so what they look for is for a degree of genetic relatedness to be a risk factor for pathology. So that if somebody has a disorder, and people who are more closely related to them genetically, so parents, children, if it's more common for those people, first-degree relatives, to also have the disorder, and not people who are more distant related to them, then that's thought to be evidence of a genetic factor. A couple of problems with that. One, the math is based on the fact that our average degree of genetic relatedness is known. So, you and your parents, if your parents are your biological parents, are thought to share 50% of your genes. Maybe not. On average, you share 50% of your genes. We don't know exactly how many of your genes you share, because they're because of some rather complex genetic factors that I won't get into here that have to do with the copying of genetic codes. So it's based on some sloppy math. And the other thing, the big thing, is that degree of genetic relatedness is typically confounded with degree of interaction, right? We spend more time with people that we're closely genetically related to than people who we're less related to, right? You spend more time with your parents than you do your cousins. So if you're more similar in terms of level of psychopathology to your parents and your cousins, is that evidence of genetics or environment? Hard to disentangle those, right? Another approach to studying genetic influence would be twin studies, where you compare monozygotic and dizygotic twins. Again, monozygotic twins share just about 100% of their genes, close to that. And dizygotic twins, share on average 50% of the genes. Again, it's on average. The biggest problem with interpreting twin studies is the equal environments assumption. And the equal environments assumption says that monozygotic twins aren't treated any more similarly to each other than are dizygotic twins. Which, if you've known any monozygotic twins, identical twins, you may have noticed that oftentimes they're dressed similar, their names are fairly similar, Timmy and Jimmy, whereas dizygotic twins, in some cultures anyway, there's less of a tendency to treat those kids as similarly. And they're also going to look more differently. And we know that the way the environment treats you is influenced by how you look, level of attractiveness. So that equal environment assumption might not be correct. And there's been research done looking at whether or not it holds up or not, and the research is equivocal. Some studies say, oh, yeah, no, it's correct. Other studies say, no, they're not equal environments. But you just got to keep that in the back of your mind. There's this kind of this caveat when interpreting results from twin studies may not be based on sound logic. Again, not to say that genetics don't play a role. They do. But when people say they know exactly how much of a role, they're probably misunderstanding or misrepresenting the data, because we don't have the research methodology, the technology to do that right now. Another approach to studying genetics would be adoption studies. Right? Often people think about this in being about those twins reared apart. And there are a couple of those studies, a handful, but they're very rare. Very rare. For the most part, it's looking either at kids who were adopted and then checking to see if the biological parents had psychopathology, and then sometimes it's the other way around. Well, we'll find parents who gave up their children for adoption, those parents who had psychopathology, and then go track down the kids and see if they have pathology and look for, are kids more similar to their adoptive parents or their biological parents in terms of these variables relevant to psychopathology. And then when studying other biological influences, a variety of techniques, including psychophysiological research, which is the study of involuntary physiological responses. There's a mixture of experimental and correlational research here. Sometimes they'll manipulate an independent variable, do something to participants and see what their bodies do, right? The physiological response. Also, they'll look for similarities in body functioning among people with similar forms of pathology. But the main problem with this research is that most physiological measures are fairly ambiguous. They don't clearly indicate a singular construct. For example, increased heart rate may indicate fear or it may indicate excitement. So it can be sometimes hard to be confident that what they say they found, what it means, really means that, because we're dealing with some kind of ambiguous phenomena. Brain imaging technology, astounding advances in the past couple of decades in our ability to look at brain structure and brain function. And we've learned a lot, but still there are no definitive norms established. Maybe because it's too expensive, maybe because there's no such thing as a norm. Some have suggested that our biochemical processes are all unique, kind of like fingerprints, and nobody is exactly the same, which makes it hard to have a typical way of functioning, like a typical serotonin level. What is that? We don't know. We don't know if there is a typical level, and if there is one, nobody's reported it. It's also important to keep in mind that the brain is not a simple organ with clearly defined regions dedicated to accomplishing single tasks. The simplest thought requires a complex coordination of multiple areas of the brain. So it's not like, oh, here's the anxiety part of the brain, here's the depression part. Not that simple. It's all the areas of the brain working together to give rise to these complex phenomenon that we're trying to study related to psychopathology. And then neuropsychology, which is involves giving tests of cognitive and motoric ability that are used to assess brain functioning. They're most often helpful in identifying individuals who are in the early stages of some disease process that's based on kind of organic brain dysfunction. And then the last question that we talk about is, how do we treat psychopathology? And the ex juventibus error relates to something that's done frequently, looking at etiology, at causes, right? For most folks, it makes sense that if you can figure out what's causing psychopathology, then you should have a pretty good idea of how to treat it. And that may be true. There are some problems with that too, but more problematic, less tenable is the position achieved when using the reverse of this logic, that if a treatment works, then we know what caused the problem, right? And that's what this error is, right? Reasoning from that which helps. So if something helps, we know it helped, then we know what caused it. This is a problem with some psychotherapeutic paradigms, but mostly it's been used. This type of reasoning has been used in the biological, medical arena. Right? If a drug is known to affect a certain neurochemical process in the brain, for example, transmission of serotonin, and people taking that drug become less depressed, then it's assumed that some deficiency or disruption in the transmission of serotonin caused the depression. And that's an error, right? Just because aspirin makes your headache go away doesn't mean you had an aspirin deficiency, right? And if we go deeper than that, right, aspirin reduces the production of prostaglandins and thromboxanes, right? So did you get a headache because you had too many prostaglandins and thromboxanes? Well, yes and no. Yeah, you may have had too many, but why? What caused that? Right? Even with something as simple as a headache, there's this kind of causal chain where something happened, or multiple things happened, multiple events or conditions contributed to the experience of pain in the head. Right? With psychopathology, which is much more complicated and complex, right? We can't even pin down exactly what it is. It seems like there's probably an even more complex chain of events that are interacting to give rise to these experiences, right? So again, the point here being that just because treatment reduces some or even all the symptoms of a condition doesn't mean you know what caused the condition in the first place, or that you could prevent that condition from returning again in the future. So in terms of treatment research, frequently we use quasi-experimental or correlational research because it's easier, but the gold standard is still experimental research, and within that, the gold standard of experimental research would be randomized controlled trials or randomized clinical trials. You might see it written, or sometimes randomized controlled clinical trials, but often whichever of those acronyms they use, abbreviating them the same as RCTs. This is when you randomly assign individuals to different treatment conditions, right? So different types or levels of treatment. And generally it involves some control group. And the control group may be a wait list, right? So we get 50 people to volunteer for the study, 25 or start treatment, and the other 25 we're going to start measuring their depression, their anxiety, their hallucinations, whatever our dependent variable is. But we're not going to treat them yet. Right? So we'll waitlist them. Or the control group might be treatment as usual. So, okay, some of them are going to get this new experimental treatment, and the other group is going to get what they would have gotten in the community, which may be, somebody to kind of talk with them briefly and check in. Right? Different types of control groups, but whatever type of control group you use when doing these RCTs, which again, kind of the gold standard, good internal validity usually, but there's maybe questionable generalizability, questionable external validity, because the folks that are going to sign up for a study like this may not be typical, right? If you're going to sign up for a study and you know that, okay, I might get the wait list, or I might get a treatment that you don't think works, right, some sort of placebo, then I probably am not on the severe end of psychopathology, right? You're probably going to get the less pathological people willing to be in that study, which again limits your generalizability. But you have a control group, and generally there's some level of blinding going on. Typically it involves at least a single blind. The participants don't know if they're in the experimental condition or not. And that can be tricky, but oftentimes when you're doing just comparing two treatments, a cognitive treatment to a behavioral treatment, and maybe the people designing the study really think the cognitive one is the best one, and that's the one that they're hoping is better. You don't tell the clients that. You don't, because they'll create these expectancy effects, and then they may look better, but it may not be because the treatment worked, maybe because they thought they were supposed to get better, and so they're trying to please you, and they report fewer symptoms. Right. So usually there's just a single blind, but often there's also a double blind where the people delivering the therapy don't know which therapy is the one that the researchers expect to be the good one. And obviously it can be tricky to have blinds in clinical research. Oftentimes, therapists are clever enough to know, okay, well, I'm seeing these clients and they're telling me not to talk about too much about their cognitions or their symptoms, but just to kind of chat with them briefly each time they come in. I'm probably in the placebo condition, right? So it may not be a true double blind in some instances. Another approach that probably doesn't receive enough attention are the single subject designs. And these are things that can be really useful for private practice counselors just looking to figure out their own kind of informal research programs of research to see what things they're doing work well and what things they're doing may not be working well. And they're really kind of somewhere in between experimental and quasi-experimental. It's like a case study on steroids. This is where you're examining one or maybe a few subjects very closely. But instead of just collecting qualitative narrative data, a la case study, you're measuring observable behaviors and quantifying the results. And different types of designs, typically though, they involve some sort of withdrawal aspect, right, where you're going to be measuring some dependent variables, some outcomes before you start treatment. Then you start giving treatment, still measuring, and then you're going to maybe take treatment away or take some part of the treatment away to see which parts work best, right? So maybe you're doing progressive muscle relaxation and some sort of guided imagery and working on anxiety. So you're measuring anxiety, you give both those things, measure anxiety, take one of them away, and then you say, okay, is there an increase in anxiety? Or if not, okay, maybe this other thing wasn't necessary. Right? So you're going to be introducing and taking away treatment or aspects of treatment. And the other thing is you're going to be doing a lot of measurement. Right? Multiple points of measurement. So it's not like pre-test, post-test. Pre-test, before you start treatment, you're going to measure at least 3 times. Right? So you're going to have a good idea of, okay, what's their anxiety like? Not just what was it like that one day before I started treatment, but in the 2 weeks leading up to treatment, what was it like? I've established some sort of pattern. Were they getting more anxious? Were they getting less anxious? Was it stably high, stably low? Right? And then the same thing during treatment, you're going to measure it multiple times. And these multiple measurements are really the key to ruling out other explanations and increasing your internal validity, right? So the breadth and the depth of your measurements, not possible with a large group, right? But with an individual, you can really do a lot of assessment and check out other possible explanations for change. So if they're getting better, you say, well, it could be because maybe something good happened at work or in their relationships. You can then go ask that person, okay, what changes have there been here, here, and here, right? Harder to do that, have that kind of flexibility in a really large-scale experimental study. But when you're doing a single subject design, you have that flexibility. Again, maybe limited generalizability. So what worked with this one person may not work with others. But if you can identify some of the fundamental things that this can work with a person, then you take that and you design a bigger study. Okay, will it work with more people? Which types of people will this work with? Right? Okay. Summing up, psychopathology is complicated, right? Because it's human behavior, and human behavior is complicated, normal and abnormal both, but especially the psychopathological. And one of the reasons it's so complicated and sometimes seemingly mysterious is that by definition it's often rare. Right? These are experiences that at the level that they're occurring to be deemed psychopathology, they're not occurring for a lot of people. Right? Some things seem to be on a continuum. Like most people experience some sadness, some level of depression at some point, but the level of depression that's seen in major depressive disorder is something that's not typically experienced. Right? And so it can be harder to understand if it's not part of your life experience, or having hallucinations or delusions, or obsessional thoughts, or any other of the aspects of psychopathology. Okay, so it's complicated, and we also, related to that, it's multiply determined. Right? For a long time there was the nature-nurture debate. Is it this or is it this? And now that debate's pretty well dead. It's been replaced by, in what ways is it this, and in what ways is it this? But again, we know it's not a matter of, okay, it's 60% genetics and 40% environment. It's not about that. It's how do genetics and environment work together? What aspects of genes at what points in time? Because genes aren't, okay, you have them when you're born and that's it. They change, right? They can become active and less active. They can become dormant. They can be activated. They can be activated by experiences. They can be deactivated by experiences, right? Somebody who has the genes to be 7 foot tall will never be 7 foot tall if they don't get adequate nutrition. Right? Even things as simple as that. It's about these interactive effects. So psychopathology is multiply determined in terms of studying it, all different strategies and tools we have for studying psychopathology. All of them have advantages and disadvantages, right? And all of them, none of them are just advantages. All of them are limited in some way, and the conclusions we can draw are always a little bit limited. They're not perfect. And because of that, your approach to studying psychopathology as a researcher will be most likely to be fruitful if you use a multi-method, multi-construct approach. And multi-method, obviously, you do more than just experiments. You do experiments, you do correlations, you look at it from a variety of point of views to help try to overcome the disadvantages of each individual approach. And multi-construct, also thinking about the constructs related to psychopathology, we look at them in multiple ways, define them in multiple ways. So depression, looking at it in terms of people's self-report of depressive experiences, looking at it in terms of brain activity, looking at it in terms of the reports of important others in their lives, their impressions of the person's mood. Right, so all these different ways of thinking about these constructs and using different methods to do it, all these things together, we're hoping will converge on some truth about psychopathology. Right, and the thing is, nobody's going to design the perfect study to answer the questions or any one of these questions. Right, it's all about conducting multiple studies, and with each study, it's not just a bunch of people that are working solo. There's a scientific community that's working together. So a study comes out, people look at it, they read it, and they see if it was done well. If it's done well, they accept the knowledge for what it is, and then they build on it. Right? They look for exceptions to rules. They look for generalizations of rules, and it builds toward, hopefully, some truth. And I'd say we are closer today than we were 100 years ago. We're not where we thought we would be, right? But for many people, the optimism remains undaunted, and the kind of hope still burns that right around the corner are some really big answers coming, and maybe. But if you want to be ready to understand those answers, and maybe even participate and find those answers, it's really important to get a good grasp of how the research is done, and especially the limitations of the different research strategies. Okay. That's all for now. Take care.